We're starting a new chapter today about rational expressions and equations. So we're going to start with simplifying rational expressions. So a rational expression is just a ratio of two polynomials. Remember, a ratio is a fraction, and a polynomial is when you have x to a power. So p of x over q of x. So you have a function on top and a function on bottom. Very important to note, your denominator, your q of x, whatever that function is, can never be equal to 0 because you can't divide by 0. So rational expressions are just fractions that have polynomials in them. So because of that, all the rules we know about fractions still apply for rational expressions. So when simplifying fractions, you divide out any common factors. So for example, 6 over 10, we divide out the common factor of 2. So when we're simplifying rational expressions, the first thing we have to do is factor. And once we've got everything factored, then we are going to cancel common factors. So 3 goes into 51 17 times, not 7. I apologize for that. And then if you have a squared over a cubed, so remember, you have 2 on top and 3 on bottom. So the 2 on top will cancel 2 out of the 3 on bottom, leaving just 1 in the bottom. And then your b's cancel out completely, leaving you 1 over 17a. Let's look at this problem. 2x plus 4 over 2. So this one is a little different because you cannot just divide 2x by 2 and 4 by 2. That's not legal. You first have to factor the 2x plus 4. So you cannot cancel, you can only cancel factors. You cannot cancel add-ins. So this addition sign means that there are two different terms. So we have to factor first. So we're going to factor out a 2, which gives us 2 times x plus 2. You know it works because if you go backwards, 2 times x is 2x, 2 times 2 is 4. So once you factored that out, you can cancel the 2's, which leaves you just x plus 2. So again, whenever you're simplifying rational expressions, the first thing you do is factor, and then you simplify after you have factored. So factoring review. Always look for common factors first. So binomials, there are a couple of rules you need to remember. There's difference of squares and difference of cubes. You have to remember how to do those. There's also sum of cubes. For trinomials, we usually use the reverse box method. So you have to know how to factor trinomials without a leading coefficient and with a leading coefficient. The box method works for both of those. Let's do x squared plus 6x minus 16 over x squared plus 10x plus 16. So again, the very first thing we have to do is factor before we do anything else. So x squared plus 6x minus 16, if I use my box method, I end up with x plus 8 times x minus 2. Now I'm going to use my box method on the bottom, x squared plus 10x plus 16, which gives me x plus 8 times x plus 2. Now that I have factored both the numerator and the denominator, I can cancel out the x plus 8, leaving me x minus 2 over x plus 2. Notice that nothing here cancels out. Nothing here cancels out because x minus 2 is a factor. X plus 2 is a factor, and those factors are not the same, so they cannot cancel. Here we have a cubed plus abc over 2a squared b plus 2b squared. So in my numerator, I notice that the only thing that these two terms have in common is an a. So in my numerator, the only thing I can factor out is an a, which leaves me a squared plus bc. A times a squared, a cubed. A times bc, abc. In my denominator, I have a 2 that can be factored out. And I also have a b that can be factored out, which leaves me 2b times a squared plus bc. Now this a squared plus bc can cancel out, leaving me just a over 2b. Here we have x squared minus y squared over x minus y. X squared minus y squared is difference of squares, so it's x minus y, x plus y. And then I go ahead and put x minus y in parentheses. I like to go ahead and just put parentheses around all my factors, so that way I don't cancel anything accidentally. So my x minus y's cancel out, leaving me just x plus y for my answer. Let's go ahead and try your skill and go ahead and try to do this one on your own. I'm going to give you a hint. For the numerator, it is difference of squares. And then for the denominator, you're going to want to use your box method. So you're going to factor first and then cancel out any common factors. You should have gotten x plus 1 over x plus 4. Now let's try this one. So I'll give you a hint. In the numerator, you want to factor out a 3a. And in your denominator, you want to factor out a 6ab. Okay, you should have gotten a plus b over 2b. Last one, x cubed minus 27 over x squared plus 3x plus 9. I'll give you a hint. In the numerator, it is difference of cubes, and then denominator, you can use your box method. You should have gotten x minus 3. Okay, go ahead and try 2 through 6 on your own.